Hello, welcome to part 2 of binomial hypothesis tests, critical regions. Today in the second part we're going to be looking at how to find critical regions for two-tailed tests. I'm going to assume you have watched part 1 and I can therefore assume that you already know how to calculate critical regions for at least one-tailed tests. So that's important to clarify. Anyway, launching into it, the first thing we need to realize is how are we meant to know whether we're meant to be doing a two-tailed test. And just like the one-tailed tests, it all comes down to what your H1, your alternate hypothesis, is. If your H1 is of the format P is not equal to a number, then you know it's a two-tailed test. And the reason for that is logically, well, P is not equal to something is quite vague. It's not telling you for sure P is less than, or in which case pointing towards the lower end of the number line. And it's also not saying P is greater than a number, which is then more definitely heading towards the upper end of the probability number line. So as it's not equal to, that means we've got to end up looking in both directions. That therefore means actually the method for calculating a two-tailed test critical region actually just reuses a lot of the skills that you already have for the one-tailed test. All you need to do is you need to do for a two-tailed test a lower tail critical region, but with half of the overall significance level. So that means if you are given a significance level for the two-tailed test of, let's say, 10%, you do a lower tail critical region that's got a significance level of 5%. And then also on top of that, as well as doing a lower tail critical region, you also need to do an upper tail critical region as well. And that's where the other half of the significance level goes, because half of it goes to the lower tail and the other half of the significance level ends up being used for the upper tail. Okay, so that's the logic. Once again, just like we said in the one-tail test video, if the default assumption is you don't want to be going over that significance level, you want to be getting as close to it as possible without going over, but there is a certain wording that can be asked in the question that does allow you to go over, and that's what we're doing with part 3, so do watch the part 3 video to make sure you know how to deal with those as well. Anyway, here is an example, and we've got H0 and an H1. Again, the H0, for the purposes of knowing what to do next, ignore the H0. The H0 is to do with other things earlier and later in the test, but for calculating the critical region, it's H1 is the bit we're interested in. So as we can see, H1, surprise, surprise, is of the format we're just looking at. So it's a two-tailed test. What a shock. We've of course got our binomial distribution, and we've been told to find the critical region for an 8% significance level. So the first thing we are going to do is we're going to take 8% and we're going to halve it to get 4%, 0.04. That means that we're both going to do a lower tail test with a significance level of 0.04, and we're going to do an upper tail test critical region, which is also going to have a significance level of 0.04. Because this is skills we looked at in the last video individually, I'm not going to go through the individual steps quite so much, but just be aware the lower tail is property of x is less than or equal to something. I'm basically playing about with what is less than or equal to, so that the output probability ends up being as close to 0.04 without going over. Then when you're doing that, the only two you end up needing to write down are probability of x is less than or equal to 9, probability of x is less than or equal to 10, because those are the two that are, well, less than or equal to 9 is the last one that's below the threshold of 4%, and x is less than or equal to 10 is the first one that gives an output that's above the threshold of 4%. Cool, so that's the lower tail test probabilities. And then for the upper tail test probabilities, again, you're doing greater or equal to probabilities, and you're trying to see, how far you can push it so that it's still below that threshold. So x is greater or equal to 18, you can see is below 4%. Move the lower bound down to 17, that makes it too much. The probability is now over 4%. Okay, but therefore, what decides our critical region? Well, again, we don't want to go over 4%. You need to write all these probabilities down, but then the ones that are going to lead to the final answer are ultimately just x is less than or equal to 9 and x is greater or equal to 18, because for both of those respective tails, those are the last sort of regions for successes that lead to a probability that's still below our significance level threshold. So therefore, the answer is the critical region is x is less than or equal to 9, union x is greater or equal to 18. You can also put a comma between there, union of course being the symbol we used in set notation, so just being consistent with things we said earlier in the course. There you go. That's how you do a two-tailed critical region. It really is that simple. As long as you can do one-tailed tests, it's just like one-tailed tests, but twice the work. You basically got to do 2 one-tailed tests in one question. Cool. So see you in a future video. As I mentioned, there is a part 3. Do watch that because that will also deal with some important things you need to watch out for when doing these binomial hypothesis tests. Goodbye.